Okay, guys, we're on the last week here. Lesson 13 is inscribed angles. Still dealing with circles. Kind of our last lesson on circles. So just so you know, what an inscribed angle is. You know, we've been dealing with central angle. So we call if the angle has a vertex at the center of the circle, that's called a central angle. Now we're looking at what's called inscribed angle, which has a vertex on the edge of the circle like this. So that would be an inscribed angle. Okay, so the definition is it has its vertex on the circle, not at the center of the circle. The vertex is actually there. Okay, and then it kind of extends out and touches the side. So it's kind of made up of two chords, you could say. So here's the big idea. What you need to know about inscribed angle is that the inscribed angle measures half of its intersected arc. Okay, I'll show you what that means. So here's a picture. So let's say we have inscribed angle B. So B is right here on the edge of the circle, and then it hits out at A and C. So we have this arc AC. So we say angle B is half of arc AC. You know, in degrees, we're talking about the angle. All right, so we got basically three examples here to do. Two easy ones and one kind of harder one. Sorry, you can see that. Angle B is half of arc AC. Okay, so here's an example. But if I give you that same picture, B, A, and C, it's inscribed angle. If angle B is 30 degrees, what's arc AC? How many degrees? Okay, and all it is, pretty simple. The inscribed angle, this is half of this, so if this is 30, that's half of this one. We times it by 2, so 60 degrees. All right, just double it. Going the other way, say I give you the arc is, let's say, 120 degrees, so it's past the 90 here, so it's a 120 degree arc AC, and then we draw it back to an inscribed angle, angle B, like that, and you can't see it, there you go. Okay, so the setup would be if arc AC is 120 degrees, what is angle B? How many degrees? Okay, in this case you divide, right? Because it's going to be smaller. 120 divided by 2, it's half. That's the definition. This is half of that. So divide by 2, 60 degrees. Okay, so the angle is half of the arc. It just works out that way. It's you know, kind of a weird property, but it just works out. And if you look at it, it kind of makes sense. You know, this looks like about a 60-degree angle, but this is a fairly far around a circle. You know, 90-degree arc would be like here, so it's past a 90, you know. So you know, by looks, you can kind of tell it makes sense. Okay, and then a little bit tougher problem. Let me give you a little side note here, and then I'll show you example number 3. Say you got like a 90-degree arc. That would look like this, right? Arc AC is 90 degrees. It goes a quarter of the way around the circle. It would have a central angle of 90 degrees, right? If I would draw the central angle in, so the arc, you know, I say 90-degree arc, 90-degree central angle, those are synonymous. The arc and the central angle are always the same. If I draw an inscribed, it's half. Okay, so say this is 90 degrees, this would be 45. The cool thing is if I draw another one down here, another inscribed angle, see how this angle down here also hits arc AC and makes this 90. This one's also going to be 45. So any inscribed angle you draw, as long as it intercepts that 90-degree arc, it's going to be half. It's going to be 45. So it's kind of cool. You can draw the inscribed angle anywhere, and it always is half of that arc. Okay, and then the last type of problem you'll see on your assignment, I think it's the last 2 problems, are where you got to write an equation, do a little algebra. So it'll look something like this. And there'll be an expression, 3x plus 40. And then in here, 2x plus 10. Oh boy. 2x plus 10. Okay, and then you got to write an equation. You say, well, how do you write an equation? You don't set them equal. You don't make them equal 180. What's the relationship? The relationship is this is half of this. Meaning, if I times this by 2, it will equal this. You know, look up here. If I times this by, let's look here. If I times this by 2, it equals this. That's a setup. So if I times that inscribed angle by 2 equals arc. That's how you set up. So if I times this by 2 equals this. Okay, hopefully that makes sense. Times the smaller one by 2, it equals the bigger one. That's the relationship. That's the equation. All right, let's solve her out there. Distributing, right? Minus 3x on each side. Minus 20 on each side. So we're getting down to x equals 20, right? We solve out that simple equation. So plug it back in just to double check. So this angle is going to be 3 times 20 plus 40. 60 plus 40 is 100 degrees. This one, 2 times 20 plus 10 is 40 plus 10, 50 degrees. So hopefully you see that that does work out, that this winds up being half of this. This is only x that makes it work. You're trying to figure out what x can be so that this comes out to be half of this. I mean, that's what you're trying to do. And that's what this equation does for you. I think that's everything you need to know about inscribed angles, guys. Let me show you actually one last thing, just in case I think it does pop up in your homework. Here'd be like a 180 degree arc. And kind of a cool property, if you have a 180 degree arc, it's going to make a 90 degree inscribed angle. So if you go halfway around the circle, it is going to make a 90 there always. You know, this is like a diameter. So I think that might pop up on your homework too. All right.